します。
Καλησπέρα σας. Είμαι Daiji Aihara. Today, okay, thank you very much. As various approaches are being made toward decarbonization, wind-assisted propulsion has been receiving increasing attention lately. Before I start, I'd like to express my respect to the pioneers who have tackled many technical challenges to reach this point. This slide shows a world-first automatically controlled sailing ship, which was built in Japan to 1980. Since then, various efforts have been made, and ClassNK has also been involved as a member in the rigid wing sail project called Wind Challenger, which was advanced by Japanese player. It was 2019 we issued AIP for this concept. Today, I would like to introduce the development in Japan, in particular related to wind-assisted propulsion system and the safety standards ClassNK has established to encourage its introduction. MOL having promoted the Wind Challenger project, has entered the operational phase of the system. A core carrier equipped with this rigid wing sail was ordered to Oshima Shipbuilding, and the ship was delivered in November 2022. This is the world's first FRP-based rigid sail. To be precise, the first to third sail are made of FRP, and the fourth one is made of steel. The sails extended to the optimal height between about 22 meter to 49 meter, according to wind speed. MOL announced that for 100,000 deadweight bulk carrier, a single sail can achieve fuel saving or more than 8% on route from Japan to North America, and more than 5% on route from Japan to Australia. Their representative presented at our seminar last year that they plan to confirm the effectiveness of the sail during the demonstration test until the end of March 2024. On its maiden voyage from Japan to Australia, that performance was high when all four sails were extended, and the reduction effect of about 8% was confirmed in the low speed range. The second ship equipped with Wind Challenger was being announced, and the installation of rotor sail being examined. To enable the installation of Wind Challenger or various ship type, MOL is developing smaller sail together with Oshima Shipbuilding. They consider producing and installing 10 to 12 units by the late of 2020s. In February, MOL also announced that two rotor sails would be retrofitted to an existing Capesize bulk carrier. Furthermore, other partnerships are progressing, looking at the first generation with half sail and rotor sails, and the second generation with multiple half sails. Other Japanese-related projects are also active. K-Line has decided to introduce a kite system. The company told Japanese media that retrofit for one ship has been completed, and they would start commercial experiments. In addition, retrofit project involved major Japanese companies such as JX Group and Mitsubishi Corporation are planned for 2023. NS United and Namura Shipbuilding are also conducting R&D on hard sails. For the implementation of this system, Classification Society provides sales standards and certification based on them. We set standard for the safety of the system itself and the safety of the base shape and the conduct survey for the checking compliance. Moreover, from an environmental perspective, other international rule for reflecting WAPS into EDI and EXI has been stipulated. We worked on its verification, R&D on related technologies or other activities. We recognize that the role of class society is expanding. Please take a look at the specific verification step. For the system design, we review drawing and conduct on-site survey, and once compliance with the prescribed criteria confirmed, we approve the product. When installing the system on ship, we review the design and conduct survey for installation. Upon request, we grant class notation. In the case, notation is optional, but periodical survey are required. As WAPS is likely include a new concept, we may also issue approval in principle as needed. We have published a standard for the system and its installation as a guideline for wind-assisted propulsion system for ship. Issued the first version is 2019. Since we have had the opportunity to be involved in actual project recent year, we have incorporated feedback from drawing review and survey as well as the recent trend. And edition 2.0 will be published next week. We are confident having significantly improved clarity, comprehensiveness, and the level of detail. Following the general section, the guideline provided required for the WAPS-based shape and survey. For the system, we have set requirements such as risk assessment, load structure, design, and material and joint, and operational and maintenance. This time, we added a chapter on driving and control system for WAPS. Furthermore, for example, for load, we have clarified and detailed the requirement of various loads such as aerodynamic load and load due to ship motion, green-sea load, other load, and these load combinations. And for operation manual, its items to be included in the manual for safe use of the equipment are provided. We have also comprehensive organized requirement for the base shape to be considered for the system installation. For example, as you may imagine, the system brings blind sector on board, and the guidelines address such issues. Moreover, the guidelines take into account the effect of the largest structure on house construction and the ship motion, and other various factors that may arise due to the system installation. We hope this guideline will help facilitate the introducing of such system. As mentioned earlier, the uptake of WAPS is rapidly increasing. We recognize that this as a reflection of industry expectations amidst the needs of various approaches towards decarbonizing ship operation. ClassNK aims to support smooth implementation of the system by establishing appropriate standard and providing appropriate drawing review and survey services in line with them. We are also looking forward to deepening our dialogue with many stakeholders, including those attending today. Thank you for your attention.